In this video, I'll talk about the RMS and peak voltage. RMS stands for the root mean square voltage. For example, let's say you have a resistor connected across an AC source, and the voltage could be in different forms. It could be in the sine wave, it could be triangular wave, and it could be the square wave. And here I have chosen the sinusoidal wave, which is Vp sine omega t. We call this sinusoidal because this one has a sine function. So how do you find out the RMS voltage? If the voltage varies as a sine function, then the RMS will be Vp divided by square root of 2. And the current, RMS current, will be Ip over square root of 2. Vp is the peak voltage. Let me write down here. The Vp stands for the peak voltage. And here in this case, this is the peak voltage here. And Ip is the peak current. And if you have a triangular wave, then you calculate the RMS voltage simply by Vp divided by square root of 3, which is and the current is Ip divided by square root of 3. If you have a square wave, then the RMS voltage is exactly equal to the peak voltage, and the RMS current is exactly equal to the peak current. How do I calculate these numbers? I will talk about in a separate video here. Just remember how to calculate the RMS voltage from the peak voltage or vice versa. If you measure the power outlet in your home, the multimeter gives you the RMS value. So the multimeter always measures the RMS values. So for example, in US, the output RMS value is 120 volt. And if you know the 120 volt, then I can calculate my peak voltage. If I look at this equation, my peak voltage will be simply equal to square root of 2 times Vrms. That's Vrms. That's what my equation is. And that means my peak voltage will be 170 volt. So now, if I have to represent the peak voltage in a graph, how do I denote it? So for example, that's the variation of the voltage. So the maximum value that it can have, we call as a peak voltage. So in this graph, this is my peak voltage here. That's my peak voltage. The RMS value would be a little bit smaller, about 71%. That is my RMS value. And this is my peak value here. So this is my peak voltage. This is my peak voltage. And that is my RMS voltage. Vrms. This is my RMS and this is my peak voltage. Always remember the RMS voltage is always smaller than the peak voltage. Okay. So in this case, this would be my peak voltage here. Peak voltage. In this case, this should be my peak voltage. Okay. So I hope you understand the relationship between the peak voltage and the RMS voltage for different kind of waveforms. In the next video, I will do some numerical problems from the RMS to peak voltage. Thank you very much. Bye-bye. Have a great time.